This is a basic outline, a stencil for doing something called related rates examples, related rates problems. Step one, you're going to take the information they give you and outline it. You're going to list the given information. They're going to give you two quantities. They're going to be functions, two functions, and they're both going to be functions of the common variable, usually t for time. Then the next thing they're going to give you is a rate of change for one of these quantities. Then they're going to give you a relationship between the two given quantities. And if they don't give it to you directly, you're going to have to dig that information out, the way that those two quantities relate to one another in the given portion. You might have to come up with that equation. And then you're going to be asked to find the rate of change of the other quantity. See, they already gave you one of the rates of change. You have to find the rate of change of the other quantity when the value of t equals a particular number, or x, or whatever the common variable will be. Step two is a solution portion. See, step one was just outlining the given information. Step two is a solution portion. You're going to differentiate both sides. Both sides of what? Both sides of the relation between the two quantities up in the first step. It's an equation that relates the two quantities that are given. You take that equation and you differentiate both sides in step two with respect to t, and you'll probably have to use a chain rule, so be careful whenever you differentiate a function of a function. And then step three, you're going to substitute the given information from the step one into the point that you took step two, and you're going to solve for the requested rate. Remember, we're finding the rate of the other quantity when t equals a particular number. Substitute that other number, substitute any other given information into the result of step two, and you'll be able to solve for the rate of change for the other quantity. Okay, now let's proceed and we'll see a particular example written into this outline. Here we're going to be given two quantities. The first one is x as a function of t. X equals x of t and y equals y of t. Both of these are functions of the same variable, t. Now, the rate of change they're going to give us is the rate of change of one of those two quantities, dx dt equals 2. And then a relationship between the two quantities, y equals 4x squared minus 3x. They ask us to find dy dt when x is equal to 3. When x is equal to 3. Okay, so first we're going to take the derivative with respect to t on both sides of the relationship, y equals 4x squared minus 3x. On the left, dy dt equals, on the right, 8 times x to the first power, then hit it with a chain, dx dt, because we're taking the derivative with respect to t, and x is a function of t, minus 3 times, hit it with a chain, dx dt, once again, because x is, not if, it is a function of t. Okay, now we're going to substitute. We've got our dy dt, and we've got 8 times 3, because I asked for x equals 3 in the find portion. Let's pause this. So we're taking the result of step 2, which was dy dt equals 8 times x times dx dt minus 3 times dx dt. We're trying to find, remember back in step 1, we're trying to find dy dt. We were given a value for dx dt. They told us in step 1 it was equal to 2. We were also given a value for x. They told us it was equal to 3. We're going to plug those values in and then isolate dy dt for our final answer. So we've already started here in step 3. We took the result of step 2, dy dt equals 8 times, take out the x, replace it with the given 3, times the rate of change of x with respect to t, dx dt, that was given in step 1, that's 2, minus 3 times, there's dx dt again, put a 2 in there. Now let's simplify this. That is equal to, that's equal to 24 times 2 minus 6, which is 48, minus 6, which is 42. So you see, we followed the steps. We outlined in step one. We wrote down the two given quantities. They're both functions of a common variable, in this case t, where we are given the rate of change of one of those two quantities, x, dx dt equals 2. We're given a relationship between the two quantities that are given. Remember the given x and y? The relationship between the two quantities is y equals 4x squared minus 3x. And then we're asked to find the rate of change of the other quantity. They already gave us dx dt, and they're asking us to find dy dt for a particular value for the variable x equals 3. Okay, that's all given information. It's been well organized. Let's do step 2, differentiate both sides with respect to t using the chain rule. We get dy dt equals 8x dx dt minus 3 dx dt. Now step 3, substitute the given information into that equation and solve for the requested rate. What information? The given information, dx dt equals 2 and x equals 3. Okay, so take the result of step 2. dy dt equals 8 times 3 times 2 minus 3 times 2, and simplify that. The rate of change of y with respect to t is 42. Now we're going to do a whole bunch of examples that will all follow this basic outline. Some easy, some more difficult.